Okay, here's our video for period and horizontal shifts. I've already created all my XY tables and their parent values, depending on whether it's sine or cosine. So if you want to take a moment and pause the video and go set up yours, please feel free to do so. All right, on this first problem, we have sine of x plus pi over 4. So remember that when we have a modification that's in the parentheses with x, that we're going to do the opposite. So this says x plus pi over 4, pi over 4. So I'm going to do the opposite, which is subtract pi over 4 from all of my x's. And then there's no change to the y's. The a and d positions would change the y values. The b and c change the x values. And the period is changed by b, and the horizontal shift comes from the c. So if I were to write minus pi over 4 with each of these original x values, you could see how I would have to do fraction math, come up with common denominators, and so forth. But what I'm going to do instead is just graphically figure out how many of these grid marks is the same as pi over 4. And then I'm just going to use that as a counting pattern. So here's what I mean by that. Here's 1 pi. 4 grid marks equals 1 pi. So 2 grid marks is half of that, pi over 2. Well, half of that is pi over 4, or 1/4 pi. So 1 grid mark is the length of pi over 4. So I'm going to take my original value at x of 0 right here. I'm going to just put my pen there. And then I'm going to move to the left, 1 grid mark. That's pi over 4. And my y value is still 0. So right here, I'm going to have a value of 0. Then my original x value at pi over 2 is right here. I'm going to go left pi over 4, or 1 grid mark, and my y value there is 1. Then my original x value of pi, I'm going to go to the left pi over 4. My y value is 0. And so now that I have these three graphed, you can see that I'm still just skipping 2 grid marks between each value. So now I'm going to go 2 to the right, and my y value there is -1. 2 to the right, down to -1. Then 2 to the right and up to 0. So here's my first cycle. And I want you to notice a pattern here. One cycle has 1, 2, 3, 4, 5 points. And we have our midline here. So the pattern is going to be midpoint, max point, midpoint, min point, mid. So middle, maximum, middle, minimum, middle. And so to fill in the left and right sides of my graph, I don't need to do a table or calculate any values. I just need to preserve that counting pattern. So starting here to the right, I'm going to go over 2 up to the maximum value, over 2 down to the mid value. And then to the left, I'm going to go left 2 minimum value, left 2 middle, left 2 max, left 2 mid, left 2 min. And that's my graph. For this next function, we actually have a y modification and an x modification. So this is an a value, which means multiply your y's by 2. And then inside we have plus pi, which means we're going to do the opposite to x, which is subtract pi. All right, so I filled in my table. I multiplied all my y values by 2, and I wrote minus pi for all my x's. And just like the previous problem, I'm not going to do that fraction math. Instead, I'm just going to figure out how many grid marks is equal to pi. So here's 1 pi. And that is 1, 2, 3, 4 grid marks. So I'm just going to shift it that way. And then here are my new y values. So my original x value was 0. So I'm just going to place my pen there. and I'm going to go left 4 grid marks, or 1 pi. Now that I'm there, I look at my new y value. It's positive 2, so I go up to 2. The next point, I'm going to start at pi over 2 and count 4 grid marks to the left. My new y value there is 0 still. My third x value started at pi. I'm going to count 4 to the left. My new y value there is negative 2. So now you can see that I'm just counting over 2 grid marks between each point. So now I have a max, a mid, and a min. So now, and each cycle, by the way, has 5 points. 1, 2, 3, 4, 5. So I have 3 so far. So now I'm just going to count over 2 and go up to the middle line, over 2, and up to the max. I just decided to brew a cup of coffee. I don't know if you can hear that in the background. All right, so now it's just counting pattern to the right and left. Over 2, middle point, over 2, minimum. Over 2, middle, over 2, max. And to the left, it's over 2, middle, over 2, min, over 2, middle, over 2, max. Now, what's different on 3, we still have an a value up front. That 2 means we're going to take all our y values and multiply by 2. And this time inside with the x, I have times 4. Well, everything that's grouped with x in the parentheses, we're going to be doing the inverse. So the inverse of multiply by 4 is divide by 4, which in other words, multiply by 1/4. So I'm gonna pause and fill in my table. I'll be right back. All right, so here are my values, and I'm gonna explain this a couple different ways, and you can stay with whichever way you like. So you can see, so after I'm multiplying everything by 1/4. So 0 times anything is 0. Pi over 2 times 1/4, I'm multiplying across the top and bottom. That gives me 1/8 pi. So you might be thinking, well, how do I know what 1/8 pi is? So we'll just think about this in terms of fractions, okay? This is 1 pi. This is half of that. Halfway between there and 0, this is 1/4, this first grid mark. Well, half of that distance is 1/8. So halfway between 0 and this first grid mark, that is pi over 8. And so that is the distance we're going to be counting. When we do our counting pattern, you can think about it like this. Halfway is 1/8. Another half is 2/8. 3/8. 4/8, right? And 4/8 simplifies to 1/2. Okay. 5/8. 6/8. 7/8. 8/8 simplifies to 1. So those are different ways you can think of to do your counting pattern. So my first point is 0, 0, so I'm going to graph that. My next point is 1/8 pi, so that's halfway between here and 1/4 pi. So my x value is there, and then my y value is 2, so I'm going to go up to 2. I'm going to go over another 1/8. That gets me to pi over 4, which is halfway between 0 and pi over 2. So over 1/8 down to 0, over 1/8 down to -2, over 1/8 up to pi over 2. So this is one cycle. So you can see how this is a horizontal compression, right? That makes sense because we took our x values and multiplied them by a fraction. So all the x values have shrunk in towards 0. So that is a horizontal compression. So take a minute and do your counting pattern, 2 cycles to the right and 2 cycles to the left. All right, here are my 2 cycles to the right and left. Pause the video so you can compare it to yours. On this last equation, on this side, this equation actually doesn't match our general form yet. Notice how here the b is outside the parentheses and x has a coefficient of 1. So we want to set that up here, and the way we're going to do that is divide 1/2 out of these terms as a GCF. And real quickly, here's what I mean by GCF. If you had this situation, 4x minus 8, and I asked you to take a GCF, you would notice that they both have a 4 in common. You would divide that out, and you would write it as 4 times x minus 2. Now that's what we're doing here, just with a fraction. I want the x to have a 1 in front, which means I need to take this 1/2 and divide it out of each of these terms as a GCF. So 1/2, the x is now going to be a 1x. So you might be wondering, well, what does it mean to do pi over 2 and divide a 1/2 out? It means you're going to have pi left. And if you distribute, you could see that that's true, right? 1/2 x minus 1/2 pi. But if that doesn't come intuitively for you, or you just want to see how that looks mathematically, we're doing pi over 2 divided by the 1/2 that we divided out here. Well, dividing by a fraction means multiplying by the reciprocal. And here there's a 2 on top and a 2 on bottom. They would cancel, leaving me pi over 1, or just pi. So now that we have our equation set up like this, we can do our xy table. Nothing is changing the y values because there's no value up front here and there's no value at the end here. But x is changing in 2 different ways. It's being multiplied by 1/2 and subtracted by pi. So we're going to do the inverse. So the opposite of multiplying by 1/2 is multiplying by 2 over 1, or just 2. And the opposite of subtracting pi is adding pi. And you're going to follow your order of operations. Multiply first, add second. So I'm going to pause the video and fill in my table, and I'll be back. All right, so 0 times 2 is 0, plus pi is pi. Pi over 2 times 2, the 2's cancel, leaving me pi. And then plus pi is 2 pi. This was 2 pi plus another one, 3 pi. 3 pi over 2 times 2, the 2's cancel, plus pi is 4 pi, and we're here. So I'm going to start graphing these. My first point is pi 1. My second point is 2 pi 0. Then I have 3 pi negative 1. Now I need to do 4 pi and 5 pi, but they're way off. So what I'm going to do instead is just do, so remember I told you how a cycle has 5 points? So far I've graphed 3, so I need 2 more. I'm just going to go to the left because the horizontal difference is pi each time, and I already know my max and min values. So I'm going to go pi to the left, which will be at 0, and then another pi, which will be at negative 1. It's the same like when you're drawing a linear graph and you can do slope in 2 different directions. You can go up to the right or down to the left. For example, if you had a positive slope. Kind of messed up my curve, but you get the idea. And then I'm just going to fill this out to the left, over pi, middle line, over pi, maximum. All right, I'm going to stop the video here and make a separate video for the 2 problems on the back.